Piniluna na hiyal eduk channel on mathematics and other related topics. In this video, our topic is about point measures. Now, let's have quantiles. Quantile is a score distribution where the scores are divided into different equal parts. There are three kinds of quantile. The quartile is a score point that divided the scores in the distribution into four equal parts. Decile is a score point that divides the scores in the distribution into 10 equal parts. And percentile is a score point that divides the scores in the distribution into 100 equal parts. Let's discuss quartile. A quartile is a statistical term that describes a division of observations into four defined intervals based on the values of the data and how they compare to the entire set of observations. Then each quartile contains 25% of the total observations. Generally, the data is arranged from smallest to largest. So first quartile, the lowest 25% of numbers. Second quartile, between 25.1% and 50%, or up to the median. Third quartile, that is 50.1% to 75%, that's above the median. And the fourth quartile, the highest 25% of numbers. Difference between quarter and a quartile. There's a slight difference between a quarter and quartile. A quarter is the whole slice of pizza, but a quartile is the mark of the pizza cutter makes at the end of the slice. So that's their difference. Example, divide the following data set into quartiles. So we have 2, 5, 6, 7, 10, 22, 13, 14, 16, 65, 45, 12. Now, the observations are not yet arranged. So, we have to order the observations. So, that's our step 1. Put the numbers in order. So, the observations, the numbers are now arranged from the smallest to the highest. So, the smallest number in the data set is 2 and the highest number is 65. Then step 2, count how many numbers there are in your set and then divide by 4 to cut the list of numbers into quarters. There are 12 numbers in this set, so you would have 3 numbers in each quartile. These are 2, 5, 6 for the first quartile, 7, 10, and 12. For the second quartile, 13, 14, and 16. For the third quartile, 22, 45, 65, the last quartile. What is an interquartile range? The interquartile range is a measure of where the middle 50 is in a data set, while range is a measure of where the beginning and end are in a set. The interquartile range is a measure of where the bulk of the values lie. That's why it's preferred over many other measures of spread when reporting things like school performance or SAT scores. The interquartile range formula is the first quartile subtracted from the third quartile. So you have here interquartile range IQR equals the third quartile minus the first quartile. Now, how do you find the interquartile range? Interquartile range in 4 simple steps. Order the data from least to greatest. That's the first step. Second step, find the median. Third step, calculate the median of both the lower and upper half of the data. Then the IQR is the difference between the upper and the lower medians. Example, determine the interquartile range of the following numbers: 42, 51, 62, 47, 38, 50, 54, 43. So, in doing this, in getting or determining the interquartile range, we have to follow the given steps. First, we have to arrange the numbers. Okay? So, the smallest data point or observation is 38 and the highest is 62. Notice also that we have an even number of observations. So, the lower half are 38, 42, 43, 47, and the upper half is 50, 51, 54, 62. Okay, so to get the quartile of the first half, you have to get the average of the two middlemost data points, 42 plus 43, divided by 2. So you get the median of the lower half, which is 42.5. Then for the upper half, you have to get the average of 51 and 54. That is equal to 105 divided by 2. That is 52.5. So 52.5 minus 42.5, that is equal to 10. So the interquartile range of the given numbers is 10. Now let's come to decile. Deciles are similar to quartiles. But while quartiles sort data into 4 quarters, deciles sort data into 10 equal parts. So the 10th, the 20th, the 30th, up to the 100th percentiles. Deciles are measures of position calculated on a set of data. The deciles are the values that separate a distribution into 10 equal parts, where each part contains the same number of observations. The decile is a member of the wider family of quartiles. The x-decile indicates the value where 10 times x% of the observations occur below this value. So we have here 100 minus 10 times x%. Why are decile ranks used instead of percentiles or quartiles? Decile rankings are just another way to categorize data. Which system you use is usually a judgment call. For example, if you wanted to display class rankings on a pie chart using deciles, would make more sense than percentiles. That's because a pie chart with 10 categories would be much easier to read than a pie chart with 99 categories. Suppose you have the numbers 15, 22, 24, 27, 32, 36, 40, 41, 50, and 90. Okay, so you have to arrange them, and we see that the first decile is 15. So the numbers are arranged, and then we see that we have only 10 observations. Okay, so you have 22 the second, 24 the third, up to the 10th, which is 90. Now let's have the difference or understand percentage and percentile. Now, percentage, this is just a mathematical value presented out of a total of 100. Then, percentage is used as a means of comparing but based on one case, one number. And we use the symbol of percentage. While in percentile, it, uh, it is used to display position or rank by comparing one case with several cases. Then, percentage of values found under the specific value and denoted by 25th percentile. So that's the difference between percentage and percentile. So the way they are used, they are presented, they really differ. Now, percentile is a measure used to indicate the value below which a given percentage of observations fall. Example, 100 minus p percent. So the 90th percentile is the value below with 90% of observations may be found. So it's really a measure of position. Okay, we have here data set 1, 2, 3, 4, 5. The question is, how many numbers are even? So if we take the percentage of the even numbers in the given data set, so percentage equals number meeting characteristics of interest divided by the total number of observations times 100. So in the given data set, we have only two even numbers and we have a total of 5 observations. So you have this one. So you have 2p times 100. So you have 40%. So 40% of the observations are even. Percentile. A value below which a certain percentage of observations lie. So we have here a data set. How many numbers do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? Now, what is the percentile ranking of 10? So you look at 10 here. Okay? Now, count the numbers below 10 so that we can determine the position of 10. So, 2, 2, that's, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 numbers below 10. So to get the percentile rank of this 10, so you have number of values below 10 divided by the total number of observations times 100. So we have here 16 over 20 times 100, you have 80%. So 10 is at the 80 percentile rank. Okay? So 80% of the observations in the given data set are below 10. So that's our analysis. Now, another data set. So I think the same data set. What value exists at the percentile ranking of 25%? So in our value here, so percentile divided by 100 times n plus 1. So we're looking for the percentile ranking of 25%. So that's why we have to add that number by 1. So we have 25 over 100 times 20 plus 1. So that is 5.25. So there is no 5.25th. So let's take the average of the fifth and the sixth values to find what value exists at the 25th percentile. So look at this one. You have to count 1, 2, 3, 4, 5. So 5, 5. 5 is the fifth observation and another 5 the sixth observation. So you have to take the sum. 5 plus 5, that is 10 divided by 2. So that is equal to 5. So it is 5, which is at the 25%. So 5 numbers. Now, quartile for ungrouped data. So ungrouped data. So you have the formula Q sub K. Q sub K equals K over 4 times N plus 1 minus K over 4 and score. So all you have to do is just memorize this one, because in getting the Q sub 1, Q sub 2, Q sub 3, you have to change the, it is the value of K. No, it is the value of K that you have to substitute. But I'm just giving this to show how it looks for every time you substitute K by 1, by 2, and by 3. So where Q sub K is the indicated quartile. So K is equal to 1, 2, 3. Then in the number of cases. For the decile, for ungrouped data, so the same thing, no? The same thing. So our K here is equal to 1 up to 9. So D sub K is the indicated decile. So N is the number of cases. For the percentile, for ungrouped data, the same thing, no? The same thing. You have to remember this one. Remember this one. For the quartile, this P is Q. For the decile, this P is D. So the same formula. No, there's nothing to worry about the P sub 2, P sub 25, P sub 77. You just replace K by the indicated grouping. Okay, so P sub K, or you have D sub K, you have Q sub K. Example, we have here data set, and these are already arranged from the smallest to the highest. The smallest observation is 6, and the highest is 20. We have to get the Q sub 1, Q sub 3, D sub 6, D sub 9, P sub 65, P sub 99. So for the solution, here, we have the header X, our observations, already arranged. Then for Q sub 1, we have to count the number of observations. We have N equals 9. So we get, so our K in the original formula is replaced by 1. So here, we have to replace N by 9. So 1/4 times 9. Then 1 minus 1/4. Then this is 9 over 4 plus 3/4. 1 minus 1/4. You can write this one as 4 over 4. Then you copy the common denominator. Then subtract the numerator. 4 minus 1, that is 3. So then we have to add these two, the same denominators. You have to copy that one. The 9 plus 3, that is 12. 12 divided by 4, that is 3. So our Q sub 1 here is the third score. So 6, 8, 10. So our Q sub 1 is the third score, that is 10. That means to say that 25% of the scores are below 10. 25% of the scores are below 10. Next, we have to get Q sub 3. So the same process. Replace K by 3. Replace N by 9. Then you have to get here the difference of 1 minus 3/4. Again, you can write 1 as 4 over 4. 4 minus 3 is 1. Copy the common denominator. Then this one, 3 times 9, that is 27 over 4. So you have it here. Then, copy the common denominators. Dayon, 27 plus 1, that is 28. So 28 divided by 4, that is 7. That means the 7th score. So you count 1, 2, 3, 4, 5, 6, 7. The 7th score is 15. 1, 2, 3, 4, 5, 6, 7. So the 7th score is 15. That means 75% of the observations are below 15. That's our analysis. Okay? Next, we have to get D sub 6, decile 6. So the same. From Q, we simply change it to D, then replace K by 6. Then we have 9 observations. So you have here to get the difference, 1 minus 6 over 10. So you can write 1 as 10 over 10. Then 10 minus 6, that is 4. So you have 4 over 10 here. Then this one, 6 times 9, that is equal to 54 over 10. So you will get this one. The same denominators, just copy it. Then add the numerators, 54 plus 4, that is 58. So 58 over 10, that is equal to 5.8 score. Now, the value of D sub 6 lies within the sum of the 5th score and the 80% of the difference between the 5th and the 6th scores. So you have it here. The 5th score, 1, 2, 3, 4, 5, that is 12. Then the difference of 14 and 12, you have to take 80% of that. So you have here 14 minus 12, that is 2 times 8.8 plus 12. So you get 13.6. Now, D sub 6 is equal to 13.6 and it's not found here. So our analysis is that 60% of the scores in the distribution are less than 13.6. 60%. Okay? So 13.6 is between 12 and 14. So 12, 12, 10, 8, 6. These are the numbers that are below D sub 6 or below 13.6. So those numbers comprise the 60% of the scores in the distribution. Then D sub 9, the same process. So we get here 8.2, but we have to determine where it is. D sub 9 lies within the 8 and the 9 score. So what are these scores? These are 20 and 16. So 20 minus 16, that is 4 times 0.2 plus 16. So you have 16.8. So that is our decile 9. Okay, so that is between 16 and 20. So 16, 15, 14, 12, 12, 10, 8, 6. These are the scores below 16.8. And those scores comprise the 90% of the distribution. Then let's have P sub 65. So the same, we simply substitute here P from QD down P. So the same process. So we get here 1 minus 65 over 100. You can write 1 as 100 over 100. Then 100 minus 65, that is equal to 35. Then 65 times n, which is 9. That's 9. You get 585. So that is the 6.2 score. Now, the 6.2 score, that is between 1, 2, 3, 4, 5, 6. So that is between 14 and 15. So that is 14 plus 20% of the difference of 15 and 14. So you get this one, 14 plus 0.2, you get 14.2. So 14.2 is between 14 and 15. So the numbers below 14.2 are 14, 12, 12, 10, 8, and 6. So those numbers comprise the 65% of the scores in the distribution, which are less than 14.2. For P sub 99, so the same process, you substitute K by 99 and N by 9. So again, this one can be written as 100 over 100. 100 minus 99, that is 1. So you have 1 over 100. Then 99 times 9, that is 891 over 100. So you have 892 divided by 100. You have the 8.92 score. So you have the 8 score, 1, 2, 3, 4, 5, 6, 7, 8. So that is between 16 and 20. So the same process. The 8 score is 16. Then the difference of 20 and 16, 9.92 times the difference of 20 and 16. So you get 19.68. So 19.68 is between 16 and 20. So 99% of the scores are below 19.68. So the numbers below 19.68, or the numbers that comprise 99% of the distribution, these are 16, 15, 14, 12, 12, 10, 8, and 6. Now, quartiles for group data. So you have to use this general formula for quartile. So Q sub K equals L sub B, that is the lower boundary, plus Kn. Our n here is the number of observations. Okay, where Q sub K is the indicated quartile, and our K is 1, 2, 3. LB, the lower boundary of the quartile class. CFP is the cumulative frequency before the quartile class when scores are arranged from lowest to highest. FQ, that is the frequency of the quartile class. CI is the class interval. QC is a class or category containing n over 4 for Q sub 1, 2n over 4 for Q sub 2, 3n over 4 for Q sub 3. Now let's have an illustration. Okay, so here the general formula. Okay, you have to memorize just this formula. Okay, and these are the results if you want to get the first quartile, the second quartile, and the third quartile. Okay, we have here sample computations of quartile using group data. So the data for the scores of 50 students in Filipino class are given below. Solve for the value of Q1. Okay, so we have to determine the n over 4. So we have here n equals 50 because there are 50 observations. There are 50 students here. You have 12.5. So our quartile class is between 41 and 48. Why 41 and 48? That is because this is 12.5, that is less than 15. Then the lower limit is 41, so the lower boundary is 40.5. You have the lower limit, subtract that by 0.5, you get the lower boundary. Then the cumulative frequency before the quartile class is 10. 41, 48 is your quartile class. Okay, so the cumulative frequency before the quartile class is this is 10. Then the frequency of the quartile class, this one, 5. Then the class interval is 8. You count 25 up to 32, 8. Then use this formula. All you have to do is substitute. Okay, so substitute LB sub 1 by 40.5, n over 4 by 12.5. Then the cumulative frequency before the quartile class, that is 10. Then the frequency of the cumulative class is 5. Okay, and the class interval is 8. So you have this. Okay, then 12.5 minus 10, that is equal to 2.5. 2.5 divided by 5 times 8 plus 40.5, you get 44.5. So our analysis, therefore, 25% of the scores of 50 students who participated in the test are less than 44.5. Again, 25% of the scores of the students, of the 50 students, are less than 44.5. Next, let's get Q sub 3. So the same thing, all you have to do is multiply the number of observations by 3. So you have 3 times 50 divided by 4, you get 37.5. So where is this 37.5? That is less than 45. So our quartile class is 73 to 80. Okay? Then our lower limit is 73. Therefore, our lower boundary is 72.5. Then the cumulative frequency before 45, that is 37. Then the frequency of the quartile class is 8. Then the class interval is 8. So, again, use the formula, substitute. Okay? Then, do the calculation. You get 72.5 plus 0.5. So, you have 73. So, our 75% of the scores in the distribution are less than 73. Now, decile for group data. So, the same thing. We only substituted from Q to D. So, there's a single formula for you to memorize for the quartile of group data, for the decile of group data, and even the percentile of the group data. This is what I said earlier, that you have to memorize a single formula. Just do the replacements. Okay? So, where D sub K is the indicated decile, our K is equal to 1 up to 9. LB, that is our lower boundary. DC, this is deciles class, decile class. Okay, then CFP, FD, then CI. So, the same thing. Okay, let's have an illustration. Okay, we have just here the D1, D2 up to D10. But as what I said, just memorize a single formula. Okay, here. Computation for decile using group data. So the data for the scores of 50 students in Filipino class are given below. So the same set of observations, the scores of the 50 students in Filipino class. So solution for D sub 5. So 5 times 50, that is 250, over 10, that is 25. So 25, that is less than 31. So our design class is 57 to 64. So the lower limit is 57. The lower boundary is 56.5. The cumulative frequency before the decile class is 19. Then our frequency of the decile class is 12. The class interval is 8. So again, you do the substitution. Just substitute. So you have here, then do the calculation. You get 56 point, this should have been 60.5. Okay, 60.5. That is our D5 or the fifth decile. So this means that 50% of the scores of the students are less than 60.5. So that's the interpretation. Again, the same set. Let's get D sub 7. So you have 7 times 50, that is 350. Divided by 10, you have 35. So 35 is less than 37. So our decile class is 65 to 72. Lower limit, 65. Then the lower boundary is 64.5. Then 31, the cumulative frequency before the decile class. Then the frequency of the decile class is 6. Then class interval is 8. So the same thing. You have to substitute here. No, substitute in the formula, then do the calculation. Okay, so you have 69.83. So this means that 70% of the scores of the students are less than 69.83. For the percentiles of group data, this is what I said. We only replace here this P, substituted D. Okay, the same formula. There's nothing to worry here. The process is the same. The process is the same. Just remember. Okay, here I've shown here the P sub 1 up to P99. Then let's have an illustration. Okay, we use the same data set. So here, we have P sub 82. So replace K by 82 and N by 50. Get their product, you have 4,100 divided by 100, you have 41. So 41 is less than 45. So our percentile class is 73 to 80. Then the lower limit is 73. The lower boundary is 72.5. Then the cumulative frequency is 37. That's before 45. Then the frequency of the percentile class is 8. Then the class interval is 8. So use the formula. Again, you just have to substitute, then do the calculation. So we get that 76.5. So the meaning is 82% of the test scores of the 50 students are less than 82% or are less than 76.5. Again, 82% of the scores of the 50 students are less than 76.5. Now, for the same set of data, we have to get P sub 91. So the same process, replace K by 91, then multiply that one by 50. You get 4,550 divided by 100, you have 45.5. So this 45.5 is less than 48. So our percentile class is 81 to 88. So the lower limit is 81, the lower boundary is 80.5. Then the cumulative frequency before 45.5, that is 45. Then the frequency of the percentile class is 3. Then the class interval is 8. So using now the formula, okay, you have to substitute the lower boundary by 80.5. This 91n over 100, replace this by 45.50. Then the CFP by 45. Then this frequency of the percentile class is 3. Okay, so you do the calculation, then you will get 81.83. This means that 91% of the scores of the 50 students are less than 81.83. That would be all. Thank you very much for watching.